you do want room for the pussies. So we're going to have to maybe take the suits out, put them in here. General prison. Well, the suits, you look at much oxygen in the cabin. Yeah, but they did use them more. Being Putting straight in. Doesn't it also fit this big container back here? Well, that's the one we want to put urine in.
I wouldn't mind something to my little piece of capability that's on 2 days without a piece of buttercup.
Hey, can't you fill some more in there? Yeah.
Then what do you do? You push it.
Now let's see, the sun's essentially to our back, Fred, so we're close to port. Let's see, what should we be doing right now? Okay, the next thing is power up to the burn. They give you time to start power up?
Now we ought to get an EOS. We ought to get an EOS.
I will. Hello, Houston, Aquarius.
Go, Aquarius.
Let's just recap the situation now. We're not going to do any more BTC. We'll maintain this attitude. You have already updated us on P30 load. We would like from you an LOS time and a power-up start time for the PC plus 2 and an AOS time.
Okay, we copy that. We're going to also get back with you shortly, Jim, with some burn guidelines for PC plus 2.
Apollo Control, Houston, 76 hours, 18 minutes. Apollo 13, now 2,623 nautical miles away from the moon, and traveling at a velocity of 5,200 to 77 feet per second. Our display shows an altitude at closest approach of 137.5 nautical miles.
Apollo 13, Houston.
Go ahead, Houston.
Jim, we were just discussing burn star monitoring, and we were curious to know if you can see Nunky in detent 2 at this time. Over.
That's affirmative. I can see Nunky in detent 2.
Okay, thank you. Roughly in what part of the field of view?
Nunky's in the upper right-hand corner.
Okay, thank you.
And Antares is barely visible at the bottom of the field of view.
Okay.
But I know I could give him an alignment. Give him a Christian spiral angle. Instead of maneuvering the spacecraft, I'll give him a Christian spiral.
Do that for egg. Give you a hip. Out of the air.
Nunkey and possibly Antares, or more likely Shala.
Roger, Jim. According to our calculations, Nunkey should be at burn time pretty close to the center of the AOT. We've been talking that possibility over.
Roger.
Also, as a matter of general interest, the sun should be at the bottom part of the CDR's window, at the bottom of the LPD vertical line.
At TIG. Where's it now?
That's a firm at TIG.
You must mean at, yeah, right, because it's behind us now.
Wait a minute, we're home in the inertial latitude.
Yeah, we're not at the big attitude.
Oh.
Apollo 13, Houston.
Go ahead.
Jim, whenever you're through eating and ready to copy the info, I can send you the burn rules.
Do you want this?
Write them right on that.
That's a right here.
Okay.
It's Apollo Control, Houston, 76 hours, 30 minutes now. We show 13 at 2,074 nautical miles away.
We're all set to go.
Okay. Okay, first of all, general philosophy is that these rules should be similar to LOI Mode 1 aboard with the tight limits. Now I'll go through them one by one for you to copy. Okay, you should shut down if any of the following happen. Thrust monitor readout 77% or below. Dips propellant tank pressure, that's the inlet pressure, onboard readout 160 or below. Fuel to Ox Delta P greater than 25 psi, and that would have to be a ground call to you. Attitude error, plus or minus 10 degrees, with the exception of the start transient. Rate limits, plus or minus 10 degrees a second. And you should shut down if you get any of the following alarms. Engine gimbal, ISS plus program alarm, LGC, CES DC, and if you get an inverter light after switching inverters. Are you with me?
Roger.
Okay.
Affirmative.
Proceeding on. If during the burn the engine stops, you have a flashing now 97, you should proceed. Then all age. Engine start to push. And descent engine override on. Okay, now just general information. If you didn't burn PC plus 2, probably PC plus 4 would be the earliest MCC. AGS is going to back up in a rate fail mode only, which you know. We're talking over the start check. We'll have to get back with you on that. If for some reason there is no PC2, you have a free return trajectory. With landing at 152.0200, and that would be after a small mid-course 5, which would probably be around 4 feet per second at 93 hours. And you have recovery forces in the Indian Ocean. You're in good shape there. And the Indian Ocean is where this landing would be. Okay, you still with me?
Roger.
Okay. After...
Yeah, I'm with you.
Okay, after PC plus 2, there are no trim requirements. And if you have a shutdown during PC plus 2, subsequent mid-course maneuvers required would, well, the earliest one would be PC plus 4. If you don't do a PC plus 2, but we still want to do one MCC later, at PC plus 4, the increase in delta V, or the penalty, would be about 24 feet per second. With a landing in the mid-Pacific at 142.4630. Now you should expect new pads, state vectors, and targets for PC plus 2 at about GET 78. Over.
Stand by, man.
Okay.
Okay, how do you read?
Loud and clear.
Okay, burn roll. We should shut down for the following. If we have the thrust monitor at 77% or below. Number 2, if the dip's propellant ullage pressure is less than 160 psi. 3, if the fuel oxidizer delta P is greater than 25, and that'll be a ground call out. 4, if the attitude error is plus or minus 10 degrees, except for starting transit. limits are plus or minus 10 degrees per second. And we're to shut down with the following alarm. An engine gimbal light, an ISS with the program alarm, an LGC, a CESDC, and an inverter light if it's still on after we try to switch an inverter. If during the burn the engine shuts down with an N97 flashing, we should throw, do manual haulage, and start push button push, and decent engine command override open. If we don't do PC2, our next burn will be at PC4. For an added 24 foot per second, we'll land mid-pack at 142.4630. Okay, we'll have the eggs up for backup rate command, or rate damping, I guess. And the free return that we're on, that we're on now, if we don't do PC2 or 4, lands us at 152.0200 in the Indian Ocean. And there's no trim requirements on this burn. And we should expect a new uplink and a new final maneuver pad from you at 178 hours.
78.
I'm sorry, 78 hours. It only seems like it's been that long.
I can understand.
Apollo Control Houston, 76 hours, 39 minutes. You heard capsule communicator Vance Brand passing to Apollo 13. The mission rules worked out.
Feedback was correct.
Okay.
The mission rules for this burn worked out by Gene Kranz with his flight control team and support rooms in mission control. These rules are akin.
Did you ever have any LOS, AOS times and a startup time for us to jump into this activation checklist?
Okay, let me poll the house again on that one.
What?
Okay, one word is in an optimum fashion, our going through that 2-hour activation generally took somewhere about an hour 15 to an hour 20.
Okay, I guess then we ought to allow you a little more than that, huh?
No, I was thinking since we don't have to do about 4 pages of it, that we probably need just about that. And that'll make up for the difference in any added time we need maneuvering, etc.
Okay.
The mission rules for the burn are akin to those on an LOI-1 with the service propulsion system. Mode 1 abort, assuming that we had no burn on the engine. We're at 76 hours, 42 minutes into the flight. This is Apollo Control Houston.
Go ahead, Chris.
Roger, we're entering the shadow of the moon now. The sun is just about set as far as I can see, and the stars are all coming out.
Okay, and if you're ready to copy, we have LOS, AOS times for you.
Flashlight. Go ahead, man.
Okay, LOS 770835. AOS 773310. Sunrise, or first I'll give you sunset, which is past, but that was supposed to be at 763245. And sunrise 771648.
Okay, LOS at 770835. AOS at 773310. Sunset at 763245. Sunrise at 771648.
Roger. We'll get back with you on the power-up time, and if you're ready to copy, have angles to load into noun 22 for your verb 49 maneuver to burn attitude over.
Okay, go ahead with the verb 49 values.
Okay. R1 plus 27210. R2 plus 35570. R3 plus 33010. Second item, as you know, do the maneuver with a proceed and a proceed, and after your add attitude, a reminder that P40 will not set you back to a narrow deadband. To get back to the 1.4 degree deadband, you have to use the procedure I gave you, which is verb 21, noun 01, enter. 3011, enter. And 200, enter.
Verb 49, register 1, plus 27218. Register 2, plus 35570. Register 3, plus 33010. And to get the narrow deadband back, we want a verb 21, noun 01, enter. 3011, enter. 200, enter.
Roger, and a correction on your first number for register 1, that should be plus 27210. And another comment after you get into the narrow deadband at that attitude, why you might tell us where you see Nunky.
Roger, will do that.
Thank you.
Okay, and you corrected register 1 is plus 27210.
Roger.
And would you like us to make that maneuver this time? It's down below us.
Stand by.
Yeah. Looks like the light is coming above on the quad.
Well, we won't get AOS, LOS until 77.
Apollo Control Houston, 76 hours, 49 minutes, less than 20 minutes now away from LOS. Apollo 13 now 1,184 nautical miles away from the moon, traveling at a velocity of 6,218 feet per second.
Now that's the AOS, is that 2 hours before burn? Just about.
Apollo 13, Houston.
Go ahead, Houston.
Jim, we recommend you go ahead and make your Verb 49 maneuver, but just stay there in Verb 49 and don't go ahead to narrow the dead band just yet. And when you're in that attitude, why, of course, then you can make your star check. And one other item is, I don't think we got back with you, but that hour 15 for power-up sounds fine with us.
Okay, at this time I'll start my Verb 49 maneuver, but will not nail the dead band, and I will take a look at Nucky. Okay, Fred.
Roger.
Almost.
is Houston. Go ahead.
Okay, we have completed our maneuver. We're in that wide deadband. Nunkey is close to the top of my display of the AOT. Right now, our antenna seem to be more closer towards the center. However, we are in that wide deadband.
Right, understand. We'll have to make a better check later, I guess.
I can't for the life of me figure out what that dark stuff is.
Did you look at it, Jack? Yeah, should be. But I didn't recall one being in that part of the sky. Black cloud.
Well, you know what this bird is flying at? 10 hours.
Yeah.
10 hours.
Less than 10 minutes away now from predicted time of LOS. We're at 76 hours, 59 minutes into the mission. We see the velocity on our displays for Apollo 13 really building up now reading 6,736 feet per second relative to the moon. Apollo 13 now 750 nautical miles away from the moon. Seven minutes away now from loss of signal. Gene Kranz going around the room checking with his flight controllers as to status of systems. We now show 77 hours, 1 minute into the flight of Apollo 13. This is Apollo Control, Houston.
It might be the debris that was thrown out there.
Boy, that extends to the cloud.
It's all dark now. From the explosion. Except that we made a maneuver. No, from our explosion.
Take a look. Covers a wide area.
Less than 5 minutes away now from loss of signal. 77 hours, 4 minutes into the flight.
Like a pair of contrails. Only if you switch the descent signal it around. Along the LOS. Sunrise.
They sure like to try to beat it too. I guess the air platform's okay. Yeah.
77 hours, 4 minutes. Apollo 13, 526 nautical miles away from the moon, traveling at a speed of 7,122 feet per second. 4 minutes now from time of loss of signal with Apollo 13 as it passes over the backside of the moon.
Houston, over.
Go ahead, Houston.
Okay, Jim, we have a little over 2 minutes till LOS, and everything's looking good here.
Roger. And I take it that we don't have to start our activation until after we receive AOS view.
That's correct.
Apollo 13 now 421 nautical miles above the moon. Just a little over 1 minute now from time of loss of signal with the spacecraft. This is Apollo Control Houston, 77 hours, 7 minutes. We've had loss of signal with Apollo 13 as it passes above the backside of the moon. We're at 77 hours, 9 minutes, and now to the flight of Apollo 13.